Dear students, this is Dr. Mohit Agarwal. Today I am going to discuss with you the positive and negative number representations in binary number system. So let me first start with the negative numbers. So there are three ways to represent negative numbers in binary number system. Like in decimal number system, we have only one way to represent decimal, any number, any negative number or any positive number. Like for example, suppose we wanted to represent plus 7. Plus 7 can be represented like this. So there is a symbol for positive numbers and there is a symbol for negative numbers also. Minus 6. So this is a symbol to represent negative numbers. This is a symbol to represent positive numbers. There is no another way to represent positive and negative numbers in decimal number systems. But in binary number systems, to represent any number, we have three different ways. Okay. In binary number systems, we cannot represent any positive or negative numbers using these symbols. We cannot represent any positive numbers like this. We cannot represent. We cannot use plus. We cannot use minus symbol in binary number system. Since in binary number systems we have only two digits, 0 and 1, we need to use 0 and 1 to represent the negative and the positive numbers. So there are three number systems, three representations. Number 1, signed magnitude. Number 2, it's a signed 1's complement method. And number 3, it's a signed 2's complement method. Let me first start with the signed magnitude method. Signed magnitude method. This is a method in which, suppose I wanted to write minus 6, minus 8 or anything. Suppose I wanted to write minus x or plus x. How to write that? Suppose I wanted to write minus x or plus x. How to write? So in this number, this x represents magnitude and this minus represents the sign. In this number, again, x represents the magnitude and plus represents the sign. Okay. So if I wanted to represent this number in a signed magnitude method in binary number system, I need to first find out the magnitude of this number. And then I need to use 0 or 1 for plus and minus. Okay. So in binary number system, we use 0 for positive numbers and 1 for negative numbers. For example, suppose I wanted to write plus 5. Now, the very first bit, or you can say the leftmost bit, or you can say the most significant bit, is reserved for the sign bit. So for plus, since I already told you, for plus, the bit is 0. This is for sign. Now, find out the magnitude of 5, which is 1, 0, 1. So this is your magnitude and this is your sign. This is how one can write plus 5. What about minus 5? As I told you, for minus number bit 1 is reserved. So for minus 1 is reserved And for 5, we can write like this. So this is your magnitude and this is your sign. So in signed representation, if the most significant bit is 1, definitely the number is negative. If the most significant bit is 0, the number is positive. So this we can write here in signed binary numbers, if most significant bit or left most bit is 1, the number is positive. The number is negative. I'm sorry, the number is negative. Number is negative. If MSB or leftmost bit is 0, the number is positive. These are the two rules. Number 1, MSB or leftmost bit is 1, the number is negative. If MSB or leftmost bit is 0, the number is positive. For example, take one more example. Suppose I wanted to write plus 15. So plus meaning it's a 0. 15 can be written as like this, 1, 1, 1, 1. So this is plus 15. What about the minus 15? The minus 15 can be written as like this. This is the method. First method, which is signed magnitude method. The most significant bit is reserved for the sign. Rest of the bits are reserved for the magnitude. This is how you can write plus 15 and minus 15. Now, one more concept here is, suppose you wanted to write plus 15 in 8 bits and minus 15 also in 8 bits. Then how to write? Plus 15 in 8 bits. Again, the first bit or the most significant bit is reserved for the sign. So if it is plus, it is 0. Now, rest of the bits, meaning 7 bits will be used for the magnitude. And what is the magnitude in 7 bit? In 7 bit, the 15 can be written like this. This is plus 15 in 8 bits. What about the minus 15? Minus 15 in 8 bits. The first bit, the most significant bit is reserved for the sign. Since it is minus, take 1 here. Rest of the bits are reserved for the magnitude. No change. This is how you can write minus 15 inside. So I think the sign magnitude method is clear to all. Now, the another method to write negative numbers in binary number system is sign ones complement method. Number 2, it's a sign ones complement method. This is another method. I will come to this why we need to have 3 different ways to represent. First, let me discuss about signed ones complement method. How to write? Suppose you wanted to write plus x in signed ones complement method. X can be any number. How to write? And suppose you wanted to write minus x in signed ones complement method. How to write minus x? Okay. So, if you are writing plus x, now very important, let me tell you one thing. All positive numbers all positive numbers in all three representations will be the same. Meaning plus 0, plus sign will be represented by 0, and rest of the bits will be used for magnitude. What does it mean? Suppose I wanted to write plus 15. How to write plus 15? The same method as we have written in a signed magnitude method. How? 0 for plus 15. Let's say we are writing in an 8 bit. 15 can be written like this. This is plus 15. So plus meaning positive numbers are same either in a signed magnitude method, in a signed ones complement method, or it is written in a signed two's complement method. So we will write down this important point. What is the point? The point is all the positive numbers will be remain same in all representation. The positive number will be remain same in all representation. Doesn't matter it's a sign magnitude method, it's a sign ones complement method, or it's a sign two's complement method. So we need to look at -6. How to represent negative numbers in sign ones complement method. The negative numbers are different. It's a different in a sign magnitude method, it's a different in a sign ones complement method, and it's a different in a sign two's complement. Now in sign ones complement method, how to write -6. This is very important. How to write -6? Okay. Find out the magnitude of x. Step number one. Find out magnitude of the number. Step number 2, take the ones complement of that number. Take the ones complement of magnitude. And then step 3, as it is negative number, put 1 at MSB or leftmost bit. What are the steps? Step number 1, find out the magnitude of the number, of the given number. Take the ones complement of the magnitude, put 1 at MSB or leftmost bit. For example, write -14 in signed ones complement method. How to write it? Step number 1, find out the magnitude of the number. So 14 can be written like this: 1, 1, 1, 0. This is 14. 1, 1, 1 and 0. This is 14. Now I wanted to write -14. So step number 1 is completed. Find out the magnitude of the number. That is 1, 1, 1, 0. Step 1 completed. Take the ones complement of this number. So ones complement, we know that how to take the ones complement. In ones complement, we invert each digit. We make 0 to 1, we make 1 to 0. Okay, so the ones complement will be 1, 0, 0, 0. So this is the ones. Step number 2. Step number 2 is done. It is the ones complement of 14. Now, what is the step number 3? Step number 3 is put 1 at MSB or leftmost bit. Put 1. So the step number 3 is put 1 and then the rest of the number. Like this. So this is step number 3. Step number 3. So put signed bit. This is the step number. So this is minus 14. This is minus 14 in signed ones complement method. Okay. Now take one more example. Let's say the problem is write minus 25. How to write minus 25? First, step number 1. Step number 1. Find out the magnitude. Magnitude is, so how to find out the magnitude? 1, 2, 4, 8, 16. So what is 25? 25 is 1, 1, 1, 0, 0. This is 25. This is 25. Take the ones complement of this. Step number 2. 0, 0, 1, 1, 0. Step number 3. Put the sign bit. This number is minus 25 in signed ones complement method. Suppose you wanted to write minus same number minus 25 in 8 bit. How to write? Minus 25 in 8 bit signed ones complement method. Minus 25 in 8 bit signed ones complement method. That means first step number 1, write 25 in first 7 bits because the 8th bit is reserved for the sign. So how to write 25? So 25 is 1, 1, 0, 0, 1 and 2, 0, place 2, 0. So this is the magnitude of 25 in 7 bit. Step number 2, take the ones complement of this number. This is 0, 1, 1, 0, 0, 1, 1. Step number 3, put 1 for minus numbers. Step number 3, 1, 1, 1, 0, 0, 1, 1, 0. So this number is minus 25 in 8 bit. And this is minus 25 in 6 bit randomly. Okay. So now suppose. So this is signed ones complement method. So I think this is clear to you. Now we will move to signed twos complement method. So now the next method is signed twos complement method. Signed twos complement method. How to write? So I told you positive numbers are same. Suppose I wanted to write plus 10 in signed twos complement method. It is same as we are writing plus 10 in a signed magnitude. We are writing plus 10 in a signed ones magnitude. Signed ones complement method. So how to write plus 10? Take the magnitude of 10. Since it's a plus, put the 0. No need to take the complement. Though the complement word is written here, though the twos complement word is written here, but no need to take the complement when you are writing positive numbers. This is very, very important. What is this? That for positive number, no need to take the complement method. Even if you are writing the positive number in a twos complement or in a ones complement method, don't take the complement. Okay, how to write plus 10? So magnitude is 1, 0, 1, 0. For plus, put here 0. That's it. This is plus 10. This is plus 10. In all the representation. Doesn't matter it's a signed magnitude, doesn't matter it's a signed ones complement method, doesn't matter it's a signed twos complement method. The number plus 10 will be the same. What about minus numbers? Okay, minus numbers. So suppose you wanted to write minus x. What is the method? Take the twos complement of x and put 1 for negative numbers. That's it. In signed ones complement method, what we have done is we have taken the ones complement of x and put the 1 for minus numbers. Here, since it's a signed twos complement method, take the twos complement of x and for minus sign put the bit 1 at MSB or at leftmost bit. For example, minus 25 in sine 2's complement method. Now again step number one, it is the same magnitude of 25, which is 11001. Okay, now take the 2's complement. The step number 2 is different. Step number 2, here instead of 1's complement, since this method is a 2's complement, take the 2's complement of this number magnitude. So 2's complement of 25, which is what? 11100. This is the 2's complement. I know you have already know how to take the 2's complement. So take first the 1's complement and then add 1. This is one method. Or copy all the bits starting from the rightmost bit till first one comes and then invert each bit. So again, so the very first bit is 1, so copy it. And since first one has been encountered, do the inversion of rest of the bits. So for 0, make it 1. For 0, make it 1. For 1, make it 0. For 1, make it 0. Like this. So this is the 2's complement of 25. Okay. Now, step number 3. Step number 3 is put the sign bit. Put the sign bit. And that is 1. So 10001 like this. So this is minus 25 in sine 2's complement method. Okay. Now suppose you wanted to write again minus 25 in sine 2's complement method, but in an 8 bit. How to write? So minus 25 in sine 2's complement method, but in 8-bit representation. 8-bit representation. How to write that? Again, step 1. Since it's an 8-bit representation, so 1 bit is reserved for the sign. So we need to write 25 in 7-bit. So how to write 25 in 7-bit? So it's a 2 more zeros here. 2 more zeros. So this is plus 25. This is 25 in 7-bit. Take the 2's complement. Step 2. Take the 2's complement. So we have encountered at the very first bit with the 1. So keep as it is. Do the inversions of rest of the bits. This is the 2's complement. 2's complement. You can write here 2's complement of 25. Now put the minus sign. Step 3. Put the bit for the minus sign. It's a 1 1 1 0 0 1 1 1 like this. So this is minus 25. This is minus 25 in sine 2's complement method. Okay. So let me tell you again. Let me take one examples again for all the number systems like this. So let's say we have a signed magnitude method. We have signed 1's complement method, and we have signed 2's complement method. And let's say I wanted to write plus 10. How to write? Take the magnitude, put 0 for the plus. This is sign magnitude method. For plus 10 in sign 1's complement method, I told you don't take the complement. Just write the magnitude and put the 0 for the positive number. What does it mean? It means the positive number is same in all the representations. Like this here also. 1 0 1 0. Don't take the 2's complement of 10. No. Just write the magnitude of 10 and put the 0. So this is a sign 2's complement method. Now, suppose I wanted to write minus 10. First, write down the magnitude, and for minus, put here 1. If I wanted to write in a sign 1's complement method, take the 1's complement of this, which is what? 1 0 1 0, and put the sign bit, which is 1. In sign 2's complement method, take the 2's complement of this number, take the 2's complement of this, which is, since first bit is 0, take as it is. Next bit is 1, so take as it is. Now, since we have encountered with the first 1, invert all the rest of the digits 1 and 0 and put the minus, meaning put the 1 for minus representations. So this is how you can write any number in sign magnitude method, sign 1's complement method, sign 2's complement method. So there are 3 ways to represent negative numbers, but in all the representations the positive numbers are same. However, there are some special case in sign 2's complement method. For example, let me tell you one more thing. Some special case in sign 2's complement method. Some special case in sign 2's complement method. And what are the special case? Suppose a number is written like this, 1 0 0, meaning this number is written in a sign 2's complement method. This number is written in a sign 2's complement method. What is the number? What is the number? Okay, so this is very special case. If a sign bit is 1, meaning the number is negative, and rest of the bits are 0, the number is directly minus 2 to the power n, where n is the number of bits, number of magnitude bits, number of magnitude bits. So in this case, the number of magnitude bits are 3. So this number is minus 2 to the power 3, meaning minus 8. This is a very special case in sign 2's complement method. However, if the number is given like this, and it is also written in a sign 2's complement method, then how to find the number? The methods are same. Take the 2's complement of the magnitude, okay, and put the minus sign. So what is the 2's complement of this number? It's a number. What is the 2's complement of this number? 0 1 1 0. This is the magnitude, and we have already taken the 2's complement. So this number is 6. Since the sign bit is 1, so this is negative. So this is minus 6. Okay. So this is how you do the reverse calculations. If a number is given in a decimal number system and you need to find out in a sign complement method, you write the magnitude, you take the complement, and you put the 1 for the negative numbers. If a number is already written in a binary sign 2's complement method and you will find out the number in a decimal, what you will do? You will do the 2's complement of this number. You will take the 2's complement of this number and find out the magnitude, which is 6. And since this number is written in a 1, this number is negative. I hope with this lecture you get an idea of sign representations of binary numbers. Okay, so we have 3 number systems. 3 have 3 representations: signed magnitude, signed 1's complement method, signed 2's complement method. Thank you very much.